Hello, good morning. Tips for assignment 2, or rather workshop 2. So we look at B1, it's right there. A simple economy. The economy is in equilibrium when two functions are obeyed. So we have, you see where we are? Yes, we have a function f of x, y, z is 0. That's the first one. We have a function g of x, y, z is 0. We're given a point. So point 3, 2, 1. Point. So check that point lies on f and g. Needs to be a common point. Two surfaces f is 0 and g is 0 define a intersection. There will be a line. Prime Minister wants to increase z slightly, so z goes to dz, and then yes, and that's all. There's no value given. So what we need to do, step 1, so this is question B1, is to calculate df and dg, both 0. That's fx dx plus fy dy plus fz dz. Same for g. And now we're going to fill in the values 3 to 1a, and then you get some value a dx plus b dy, another value b, plus c dz, after you fill in the point 3 to 1 in those expressions. And likewise, we get that for 3 to 1. We get a sum involving dx, dy, and dz, whatever it is. And then the second step is to solve for dx and dy. So this would be e dx plus f dy plus, oh, I have already an f, so that's not wise. So let's say h dy plus hi k dz, and these are values which you obtain after evaluating the function derivative, the partial derivatives in the point. And now we are going to solve for dx dy given these two equations. So solve for dx dy in terms of dz. And then we have x plus dx, y plus dy, and of course z plus dz. So given dz, and it says dz is bigger than 0, what is dx and what is dy? Is it going to is it positive or negative? So that's what you need to do. So B2, oops, B2, why is it doing that? Yes, B2, we have a function 4xy squared. So let me see where we are. There we are. So 1, we have a function fxy is 4xy squared in a point 2, 3, and then in which direction is f in the point 2, 3 increasing most rapidly. So you have to calculate the grad of f. So that counts actually for all of them. So for 1, 2, 3, you calculate the gradient of the given function. It doesn't say f, but I've given it the name f. Then you evaluate in the point. Here that's 2, 3, so you get two values here. and then you have to find in which direction the increase is most rapidly. So recall that if you have a factor, it needs to be a unit factor. U grad f is the modulus of u, is a unit factor. So the modulus is 1, the modulus of grad f, and then cos theta, where cos theta is the angle, cos theta is the angle between the u and grad f. So basically I have to say where the direction in which cos theta is maximum, and then in the next one it's decrease, so it's where cos theta is negative and most negative. Yes, and so that's for 1 and 2 what you need to do for. So this angle is theta, so it's basically you have to look, see whether theta is 0, theta is pi, or theta is pi over 2, and then draw these figures for each case. Here the increase is most rapid. What's the direction of u given the direction of f? So what are we supposed to do in 3? Find the unit normal factor to the surface at the point, right? So we need to calculate grad g, then evaluate in the point 1, 1, 1. So we get 3 values, and now you have to find the normal factor. So the normal factor, you have to think about where that is if you have a surface, right? What's the alignment of what's the direction of the normal factor? So you know that when you're in the plane, say g is 0, then the factors are tangent, and you are looking at the normal factor. So you can have g is 0, but you can also have an other g, say g is -1, I'm just drawing it, or g is very close to 0, so you could say g is epsilon, minus epsilon. So then how do I go from one g to the other? What is that direction? So think about it. Oh, I should give the answer away. So this is B2. B3. Find the equation for the tangent plane. This is B3. There we are, B3. Find the equation of the tangent plane to the surface. Set is fxy. So set is fxy is x squared plus y cubed. Right, so and we have to give it in the form of a plane, which is tangent. So x plus by plus c set is d. So we can write this as a function of gx, y, z is z minus x squared minus y cubed. Then we can calculate grad g, and we evaluate that at the point 1, 1, 2. So we get 3 vector with 3 components. Now we need to find, so this relates again to B2, we need to find the normal to G at 1, 1, 2. So what is the relation between grad G and the normal? The normal factor, by the way, does not need to be a unit vector, you can do that, but you don't need to do that in order to get the plane. So if you have your normal with components n1, n2, n3, right? So you need to find out what the relationship is with grad g. Then the plane has the following form, given that normal. And then what do you put on the right hand side? What is d? Well, d is simply n1 times 1, so that's the point first component, plus n2 times 1, so that's simply and then the n3 times 2, so that's the inner product of the normal with the point. So let me call then the point x0 is 1, 1, 2, so that's inner product with the factor x0, because then you know the point lies on the plane. You just give this is set, of course, because it's right here. So basically a, b, c are n1, n2, and 3. So that's it for the hints. Good luck.